out to me about whether I could work for them and apply some of these deep learning techniques and NLP to their business problems. And I felt like, well, if I just go in one company and I solve that one problem, I feel like the technology could actually be so much more broadly applicable, and ideally I'd write it once really well in some generalized platform, and then lots of people can use it. And that's why it was called MetaMind. Sort of supposedly, the hope was to eventually have lots of different sub-minds that have one MetaMind, and that keeps getting smarter and smarter. And then we built a lot of technology. It was fun. We did some research. We had some customers. We worked with the largest teleradiology company in the United States, VRAD, saving lives with like having deep learning run in production there. Did some fun research on natural language processing, and then we're sort of at a stage where it was just about scaling sales and marketing more and less about the technology. And the team and I basically felt like, well, what better place to partner with than Salesforce and their epic Salesforce, because they also, whenever they solve a problem, they just solve it for one of their customers. It wouldn't ever scale because they have over 150,000 different companies as their customers, and so it's like 150,000 different kinds of apps. And if you just build sort of an AI or any kind of classification algorithm to be more precise, it wouldn't scale to their kind of scale. And so it was a really exciting move, and I'm just gonna.
So I run the natural language processing team at LinkedIn, and we do a lot of cool things. And lots of deep learning, which is why I'm here. And before that, I was actually a senior research scientist at Google Research, where I worked both in NLP-ish problems as well as speech recognition. Anyone in the audience have an Android phone? All right, a couple of you. So yeah, all right on. I like both iOS and Android. I'm equal opportunity. But so if ever you've used what I guess is called Google Now, but if ever you've had that thing where you want to say something and have something done on your behalf, like send an email to so-and-so with the message, I'm running late and the subject late, or tell me how tall Barack Obama is. So that's our semantic parser that I built with a couple other guys at Google. So that was another fun project to do. And yeah, amongst others. So at LinkedIn, there's lots of text, which is a lot of fun to deal with because we have tons of text in multiple languages and structured information often connected to it. So it makes the problems even more interesting, even more fascinating. The text itself is interesting. We have obviously many genres of it. One genre that's of particular interest is profile text. So your profile is like, right, your modern version of a resume. People write differently. First of all, they try to write cleanly, and they tend to omit subjects. In linguistics, you call this a pro-drop language, right? You don't need to say that it's you that did this stuff because it's obviously about you. So the language is different, and we are trying to essentially find semantic representations so we can solve a lot of the problems that are of interest now and in the future for LinkedIn. For example, if we can find good representations of profile text, of job listings, we can perhaps find good ways of saying, yes, this would be a great job for this person. Or similarly, for people, we might be able to do a better job at suggesting, hey, these are people that you might want to know. So there are lots of problems like that, and then some. And we work on all of them.
Okay, great. How about Carl?
Cool. Thanks, Jordan. So I'm Carl. Been here at Baidu a couple of years. So before that, I cut my teeth in startup land. Working at a company that was doing machine learning for anti-fraud fraud detection. So in my time here, I'm now a research scientist in Baidu's Silicon Valley AI lab. Done a lot of work on speech recognition, and then more recently have been running a small team focused on natural language processing, especially for language understanding applications like the ones that Dan was talking about, because as you might imagine, if you have a speech recognition system that you want to get in the hands of users, you might want some other technology to go along with it. Yeah, I think the mission of Baidu's AI Lab is to work on hard AI technologies that let us impact hundreds of millions of users, which is, a big statement. I think it's good to have big statements, but it does mean something concrete, right? Which is that I think there's really valuable and useful AI research to be done where there's not a clear sort of short, medium-term path to having a big impact on a large number of users. And that's really great and worthwhile work, but that's not our focus. There are also really great ways to have impact in technology that have nothing to do with AI. I know that's heretical in 2016, but I think there's plenty of work to be done, not in deep learning, which is great work, but that's also not what we're about. We want to sit at the intersection of those two things. One of the other things that I think is pretty exciting about being at Baidu is, this may come as a shock to some people, but it's a Chinese company headquartered in Beijing. And so a lot of the problems we've worked on in places where, in my background, you only work in English, you actually even start by assuming that you're going to be working at least in English and Chinese, if not more languages than that. And so our speech recognizer, for example, the deep speech system, is essentially the same system, and it works both in English and Chinese. And actually, one of the guys on my team who led the development of the Chinese system does not speak or read Mandarin, and was still able to build I'd say it's probably the best Chinese speech recognition system in the world. That might be controversial, but I think it's true. And so, this may or may not come up, but I think this is one of the exciting promises of deep learning, and I think whether it's going to be true in NLP as well is an open question. But being able to attack problems without the same deep domain knowledge, instead using powerful general purpose techniques is an exciting opportunity.
You connect with someone and then you get their email address and you can just sort of go about asking questions that way to learn?
Sure. I mean, that's one way. Or you can be, in a very private setting like this one, where it's just the two of us, and you learn new information. But I mean, there's always that little extra layer of, there's your professional persona, and then there are the few personal things that probably don't belong in your professional persona, but that's, So we have actually a tradition at LinkedIn that for every batch of new hires, 3 are randomly selected to talk about themselves, introduce themselves, say one thing that's not on your profile, and then exhibit some special talent.
That's great.
So yeah. I'm not going to do that here, but I will happily attempt to do so if I see you after this.
The problem is that this is going on YouTube afterwards, so it'll all end up online anyway. The current applications that you're trying to build right now, beyond the sort of historical view that we've all provided so far. So for example, Richard, you have this Salesforce research thing. What are you sort of working on?
That's you could probably talk an hour to give the answer to those 3 questions. Let me try to split it into 2 things. So I'm the chief scientist. I care a lot about research and actually publishing papers and pushing the state of the art in artificial intelligence forward. But then I, of course, don't do that in a vacuum. I also want to see some of those things that we do, not all of them, but a subset of the things that we do in the research group to also impact all our customers. And so let's start with maybe the research, because in my view, a lot of ideas sort of germinate and start in research, and then they incubate in research groups for a while, and then they sort of graduate out of those kinds of groups into engineering groups and product groups, and then they have impact on normal people. And so on the research side, I am very excited about multitask learning. I think as a field, especially thanks to deep learning, we can take any kind of data set now, as long as it's reasonably large, and we can train neural network models, deep learning models, which is often quite similar, but the standard sort of definition of a neural network doesn't encompass all the various bells and whistles that we now put onto these models, like attention mechanisms and various modifications like that, and memory architectures and so on. So that's why I would say deep learning for most of the rest of the talk or the panel. But basically, we're very good at taking a single task and optimizing it and getting really high performance. And so as a researcher, I feel like we've done that. Now what's the next level? And I think the next level is to not start every project that we do at some random point with random weights and retrain our model for that new task. But ideally, we'll actually continue to train a single model that just gets smarter and smarter over time.
And only if we do that will we actually ever get to a truly intelligent, even just natural language processing system. And of course, after that, maybe we'll have to combine other modalities, visual modalities, databases, and so on into that single system. Now, that's an interesting research problem because it's not solved yet. Next week, we'll publish a first paper on this, where we'll take a first stab at that problem and have a single model that solves 6 different NLP tasks. But there are hundreds of different NLP tasks, and ideally we would solve all, right? When you try to train a language model or a machine translation model, it will only ever predict things because in the end, there's like just a standard classifier in most cases, and the decoder. Now, another paper we're just publishing next week, actually it's now already on archive/ICLR, so one of the great conferences of the field, the International Conference of Learning Representations. We actually incorporate into these deep models a pointer, so you can point to words in your test set and actually predict words at test time that you've never seen at training time. And that's like a fundamental issue that I think this kind of work tackles. And then there are a couple of, you can get even more technical. I don't know the sort of preference of the audience, but I think the most technical thing is that a lot of people who here knows word vectors, like word to vector. All right, awesome. All right, so word vectors are great, right? Everybody loves word vectors, and embedding all the things all the time. With sometimes some ideas to how we embed word vectors. Now, the problem is when we have an encoder, we'll have word vectors, and when we have a decoder, we have, again, a classifier, and often a classifier for every single word. Now, that's suboptimal, because then really what that means is you have 2 types of word representations, one for an encoder and one for a decoder. And so with the project that I've done with 2 of my students from the Stanford class, we actually tied those 2 word vectors together. So we have a single word vector representation for both inputs and outputs. And it's, again, one of those fundamental issues where, like, this doesn't really make sense. This is, like, a lot of parameters, usually, 100 times, 100,000 different weights that you want to learn, and you're not sharing statistical strength between the inputs and outputs. So anyway, I could go on for a while. Next week we're going to have 5 papers. I'm super excited right now. The deadline is also tomorrow, so I'm going to run back to the office right after this. Now, on putting the research aside on the applications, there's so many things, and in some ways we have to start at just the simple stuff, like image classification, document classification. And just those 2 things can already be super duper impactful, so you want to make sure they scale well, they're very robust. And sometimes there's actually a back and forth between research and some of those applications. You would think image classification, that's pretty much done, but there are actually a lot of subtleties when you want anybody to be able to train their own image classifier. So let's take, for instance, we can all train on a balanced data set and separate out cars versus Matthews. That's super easy, and you have 1,000 examples for each class, and it's like, okay, that's done. But now you might have customers that come and say, well, here's my company logo. Here are 50 examples of my company logo. Now go and find them in the 1 million or 1 billion Twitter images for the next couple of weeks. Now, all of a sudden, you don't have a nicely balanced labeled data set anymore, and you still want to solve that problem. And that actually then becomes kind of an interesting research problem. How do you deal with super skewed data sets and things like that? So sometimes you can go back to things you thought were solved from the research side and actually, in real life, see that there's still work that needs to be done. So image classification, we're continuing the medical work that we had started at MetaMind, and then also apply it to Twitter and marketing. And then on the text side, of course, text is even more important than images, at least for Salesforce, and there's just so many things that you can do if you have a very solid, even just classification engine. So Salesforce, for instance, runs a lot of customer support centers. And so whenever most of us are customers of some company that likely uses Salesforce. And so they're kind of one step removed from normal customers, because they're often their customers' actual companies. So there's one recursive set there. But in customer support centers, as an email, for instance, comes in, you might want to automatically assign who would be the best person to answer that, or in some cases, they're super simple, like, oh, how do I respond to this email? How do I recover my password or something like that? Whether you see it many, many times, you might just want to automatically send an answer to some of those kinds of things. So for a lot of interesting applications in the service, sales, and marketing worlds,